All right. My last AP1 class, second period, I went and I wrote all of this stuff down on the board to help you guys out, and I recorded the whole thing, and I told people that were there that I was going to post it online, and I was going to edit the video to cut off the beginning and end and stuff, and I realized that there was no volume, there was no sound, because I didn't have my little microphone on. So I'm going to record this one, and while I was there, what I did was I went through the old video with all my handwritten scratches and stuff, and I typed it up to make it a little bit cleaner. But what I'm going to show you is not what the report is, it's what would work on the report, what would be a good report, so that you guys can see it and can consider it when you're writing your own. You're welcome to borrow some of my phrases, but I'd still like to see it in your own words. What I'm going to use is I'm going to use this lab report format that I handed out to you, which is also on Canvas, and this guy right here, the scoring rubric, to go through and see what would make a good report. So the first thing talks about an introduction. It says, state in your own words what the experiment was supposed to accomplish and what questions it was supposed to answer, what actions you performed, and how those actions helped you achieve your objective. So when you see something like that on an AP test, when it tells you something like that, they just gave you a list, like a checkbox of things that you need to take care of. So you need to take care of every single thing on that list. And so those are the things that we're looking for in this. So the first thing, where did we get our purpose? And the purpose we got was from the essential question, which is on every page of the Canvas stuff, so you don't need to write any of this down. But the essential question said, what are different ways that experimental data can be used to show distance, velocity, and acceleration in graphical form, and how are they related? Okay, so how can we show it, and how are they related? So that's what our purpose or goal is. So the first thing that I thought of was, how am I going to rewrite that as a purpose? So in this experiment was designed to show the relationship between distance time, I abbreviated, velocity time, and acceleration time graphs using experimental data obtained from two toy vehicles, one of which moved with constant velocity and the other which accelerated. So I've just told basically what I'm doing, showing this relationship, and how I'm getting the data. So another thing that it says, what actions you performed and how they helped you achieve the objective. A spark timer was used to measure the distance traveled by the vehicles as a function of time. The data was recorded and used to determine total distance and velocity. And it was graphed to show the relationships among the graphs for each vehicle. Okay, so my goal, how I did it, and how it helped me, right? So I've answered all of those questions. If you go to the AP Physics scoring rubric, the one that I gave you, there are two things that all of this comes down into. One, is it clearly stated? I think so. And is it clear and concise? Now, I put these in bullet kind of points. When I wrote this for second period, it was a paragraph. And I was just writing as I went, right? But I wanted to be able to split it into sections, and so for PowerPoint, it kind of made it look like these are bullet points, but they're not. This is like a paragraph, okay? So that takes care of the introduction, 5 points of our 60. So the next part is the experimental procedure. In your own words, describe what you did. The procedure must be clear, i.e. a person who has not done the lab must be able to understand and follow it. So if you look at your procedure and you pretend like you've never done it before, could you do it from what you wrote? It should include a list of all materials used, a diagram of the lab setup if appropriate, okay, and I told you guys you didn't have to do it for this lab, and the steps taken to accomplish the lab, Paragraphs are preferred, but organized ordered lists of instructions are acceptable if the list items are written in complete sentences. The written procedure must demonstrate that you understand how the experimental data was collected. Okay? If I read your procedure and I'm thinking they have no idea what they're doing, then you're not going to get credit for it. All right? So, the procedure on our actual point scale here clearly describes it as worth 5, and it's easy to follow and understand is worth 5. So this second part is worth 10 points. So, what did we do? And we'll do this in paragraph form. Data was collected for 2 toy vehicles. And then I went on and described them. I didn't do this in second period, I don't think. A battery-powered dune buggy that moves at constant velocity, and a spring-powered toy school bus that accelerates when released. Okay. I didn't say how they were powered, battery-powered versus spring-powered, second period, but I threw that in when I was typing it up. So, data was collected from these 2 things. So, that's a general statement. The vehicles were attached to a paper strip using tape. A spark timer made marks on the strip at constant time intervals of 0.1 second. These are, which I called ticks, or this was also at 10 hertz. So I've told what I did. I taped a piece of paper to the spark timer, which made those markings. After 1 run for each toy, the distance between the marks was measured with a ruler in centimeters. So what have I talked about now in terms of the materials list? I've talked about my 2 toy vehicles, I've talked about my spark timer and my tape, and I've talked about my ruler. So all of my equipment that I used has been mentioned here, right? And what it does. I used the ruler to measure in centimeters. The data was recorded in a table for graphing. The total distance traveled was calculated with respect to time, and the acceleration was determined for each time interval. Now, I didn't mention how I did that. I'm going to do that when I get to my raw data. The average velocity was directly measured for each time interval, as it is the distance traveled, and this is delta t. I didn't have a delta sign on my keyboard, right? That's delta d, rather. So, that greater than, less than, a lot of times when I'm typing fast is how I make it try and look like the little triangle. Okay? Delta d per time interval. So, graphs of distance versus time, velocity versus time, and acceleration versus time were produced for each vehicle. A best fit line was drawn for all linear data. Slopes were calculated where appropriate. Okay. And lastly, the dune buggy accelerated from rest before achieving constant velocity. So the first 2 data points were discarded when the best fit line was drawn. 2 data points, my 2 data points, maybe not your 2 data points. I just made up some data, which I'm going to show you in just a second. And I made up data that I'm going to have to not include in my slope. All right. Okay, so here's some data that I made up. I only made up the first 6 points, so that I have room to write over here. But let's pretend that this is your dune buggy data. Now remember, this column wasn't on there. We had to kind of add that. So we only really had this column and this column for calculations, or for data collection, and we calculated the others. So the distance traveled per tick mark on the spark timer strip represents the average velocity for that unit of time in column 2, right? Delta D, change in time per tick, so that's that. Summing the change in distance over time gives us the total cumulative distance traveled at any specific time, column 3, as shown in equation 1. So, why am I writing all that stuff? Let me go back to experimental data. Experimental data. Provide your data or tables sample calculations for each piece of calculated data and final results in this section. Write a short paragraph which demonstrates your understanding of what happened in your experiment. It'll probably be qualitative, but not always. Okay, so is all my data included? Is it presented in an appropriate format? And do I have correct units and sig figs included with the data? Those are my point things that I'm going to score points. So this says equation 1. So what does equation 1 look like? I can do for point, let's see, I can label this equation 1. For point 2, total distance is equal to delta d1 plus delta d2, so it's equal to 2.1 centimeters plus 3.5 centimeters, so it's equal to 5.6 centimeters. See? So I just did an example calculation for that point, didn't I? Okay? That's all you have to do for an example calculation. Calculate 1 point, and you're done. The average acceleration during each time interval, column 3. Oh, did I get the columns wrong? 1, 2, 3, 4. Column 4 is what that should be, I guess. Column should be 4, which means this should be... Oh, yeah, I just forgot that one. Okay. By subtracting the previous distance traveled per time interval from the current time interval. What the heck does that mean? Okay. So... that's just how I chose to describe how I calculated the acceleration. So, and I called this, did I really call this equation 3? So I had no equation 2. There we go, equation 2. So equation 2 for point 2, acceleration is equal to, so what did I do? For this point, I did this minus this, didn't I? So that means delta d1, d2 minus delta d1. So that was equal to 3.5 centimeters minus 2.1 centimeters. So it was equal to 1.4 centimeters. And this is centimeters per tick. Centimeters per tick. So this is centimeters per tick. And then my acceleration is, this is for 1 tick. So my acceleration really is centimeters per tick, right? So I showed my example calculation. What do you mean? Oh, yeah, why did you show that? So, on the form, if you were using the form that I gave you, I would show it just off to the side next to the data points that you're doing your calculation for. Otherwise, I would write it right underneath. Okay, if you were doing this in a long paragraph form, okay, or in a long, like a report, like if you're typing it up, I would put the example calculations right underneath. Now it also says in here, a short paragraph which demonstrates your understanding of what happened in the experiment, probably a qualitative statement. Okay, so I've been talking about what happened a little bit, but I'm going to add to that and say the uniformity of distance between the marks for the Dunebuggy indicated that it was traveling at a constant velocity, or nearly constant velocity, after the first 2 ticks. When you picked up that data strip, could you see that all those were really close? I mean, to the same length? They were the same, like same over and over and over again? So that's an observation you can make, right? The first couple of ones maybe weren't, and I made up a couple that didn't fit when I made up this data. Because the Dunebuggy was accelerating from rest, and I made this up too. Okay, this may not have happened for your data, or it may have happened more. I said because the Dunebuggy was accelerating from rest during the first 2 ticks, only the latter data points were used when determining the slope of the distance time graph. So basically, I said the first 2 ticks I didn't include in my slope. And then for the school bus, yada yada. You're going to do the same thing for the school bus. Mention some stuff, show your calculations. The calculations are exactly the same for the school bus, aren't they? Okay, so but you'll still show your example calcs, and then just discuss what happened. Are you going to talk about how uniform distance between the school bus, how the marks were a uniform distance for the school bus? No, you're going to talk about because the distance between the marks for the school bus got larger and larger, it was clear that the school bus was going faster and faster or accelerating, right? So something like that. All right. So let's talk about the graphs. So now we've talked about the data that we collected, the experimental data. So now let's talk about the analysis. Include the analysis of the collected data when using graphical analysis. Include all graphs. So that's one thing. When calculating results, list sample calculations for all calculated values. We didn't have any new calculated values other than slopes. So the slope of the line I would expect to see on your graph. In your own words, explain the reasoning behind the method for obtaining the final results. In most labs, the analysis section includes a number of questions that need to be answered. We didn't have any of those, but provide the answers to each question. And then the last part here, describe the limitations of the experiment and or procedure which affected the precision of your results. When actual values are known, calculate percent error. Discuss how your results can be improved. Note, reports that include the phrase human error will be returned ungraded. That is not an acceptable answer. Okay? Those are called mistakes. Well, I could have done the equations wrong. Well, then fix it. Okay? And besides, it doesn't even sound like you did. It sounds like you might. Right? So you're guessing. You might have done it wrong. That's not a source of error. That's not being decisive. You either did it wrong or you didn't. Right? If you did something wrong, fix it. All right? Sources of error. You need to read that paper about sources of error. Those are included in every single lab, and those are not mistakes. Be specific. Well, things were kind of hard to measure. What things? What measurement? Be specific. So this all goes into the analysis, so let's talk about that. First of all, I'm going to draw some graphs so that we can talk about our graphs. Okay, in the first data graph that we did, in the first distance versus time graph for the Dunebuggy, so let's pretend that my first two data points look like this. Right? Now, I had mentioned that I threw out two data points. So I'm going to make a note of those by circling them like that. Then I'm going to do my drawing with a ruler. Do not turn in something to me that was drawn with your shaky hand or connect the dots. Okay? Because if you're connecting the dots, how do you get a slope? You can't get a slope because the slope is different between every single pair of dots. You cannot get a slope from that. So don't do it. Remember, we're trying to get averages and from a best fit line that have some value, some meaning. So I'm going to draw a best fit line that's going to look something like that. Notice I got some points above and some points below. I do not have to do anything about these points because I said I don't think that they fit. I don't think that these are legitimate points during the constant velocity portion of the motion of the Dunebuggy because it had to get up to speed, right? Now, if I want to show this and show it as like a curve for acceleration, then I'm going to label that. Period of acceleration, right? But I've already talked about in my text how I remove those points from my average. So when somebody looks at this, they go, hey, that line doesn't go through those points or anywhere close to those points or whatever. That's fine. I've discussed it, right? If I had included those points in my average, my line might be like this, right? And that wouldn't be realistic for the constant velocity portion of the Dunebuggy. Okay? So I removed those intentionally, and I mentioned it. And I mentioned why. And I have a good, legitimate reason, right? Scientifically based. The dune buggy cannot be going constant velocity immediately. It has to speed up, right? What did I say about it? For the graphs produced at the constant velocity, the slope of the graph, I said figure 1. So this should have a title, distance versus time for dune buggy. So it has a title, but I'm also going to call this figure 1. And that way I can refer to it without having to write out the whole freaking title. Right? For graphs produced for the constant velocity dune buggy, the slope of the distance time graph, the distance versus time for the dune buggy graph, wouldn't that be long? So, figure 1, excluding the period of acceleration from rest, so I've mentioned it again while I left those points out, approximates the value of the y-intercept of the velocity time graph shown in figure 2. So let's do figure 2. So figure 2 is velocity versus time. Now, my time intervals are the same on both these graphs, right? They go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? But my distance up here, it goes from 0 up to maybe, I don't know, 100 centimeters. Most of your papers were about 1 meter long, right? So my distance may go up to 100 centimeters. But did my velocity go up to 100 centimeters? No. If this has the same scale, and my velocity is about 4 centimeters per second, or per tenth of a second, 4 centimeters per tick, where are all my dots? They're like this. That's horrible. Okay? You need to make sure, even if the time scale is the same, the vertical scale is not. Make this like 1, 2, 3, 4, 5, 6, or something like that. Something reasonable. Okay, now my point, well, I still have my my first couple of points, right, that are oddballs. And then after that, I've got my points that look like this, right? So what do I do with these first 2 points? Well, I've already told you that I'm excluding those first 2 points from this graph. So it's the same thing here, right? So now when I graph those other 2 points, what does that look like? Does it look like some kind of weird, funky curve? I hope not. Yeah. I hope it looks pretty close to something like that. Well, okay. Let's pretend like I drew a better straight line. All right? Can I do something like this if I want to? Sure I can. As long as I label this, I'm going to say that this is my period of acceleration. And I want to reference that in my document. You know, that during the period of acceleration, you know, those points were thrown out. But anyway, so I've got this. Oh, and I said that the slope of this matched this. So where do I get my points for my slope? From the what? Yes, from the line. I don't use data points. If I find some point on my line, like this point, and I can use those to calculate the slope. And I can do that right on my graph. Slope equals change in distance over change in time equals d2 minus d1 over t2 minus t1. And then substitute in these values. Make it clear that you're not using data points, that you're using points that were conveniently picked from the line. Maybe they went through the vertices of some of the squares or something, or were easy to find. Because none of these points, none of my points are actually on the line, are they? So I can't use them, right? And even if they happen to be on the line, you shouldn't use them anyway. It's bad practice. Use your line. Your line is what matters, not the data points. Okay, so the first two data points were not included in the determination of the best fit line. The value of the slope of the velocity time graph, which is 0 for the Dunebuggy, I abbreviated, is also the value for the intercept of the acceleration time graph, which also demonstrates no acceleration. So I basically just said, here's what the acceleration graph looks like. So we have acceleration versus time, and now we also had some period where the Dunebuggy was actually accelerating, wasn't it? So we had some points that were like this, and then they started being, on the line or close to the line, like that. So we can mark these as not being included, and then when we draw our line, our best fit line, where's our best fit line? Boom, right there. Can I show that there was a period of acceleration right there? Yeah, I can do that, but I probably want to label that period of acceleration from rest. Actually, I made it a little bit different on each one. You should make them consistent. Call them the same thing, because they're the same points, aren't they? Aren't these 2 points, which are those 2 points? Yeah. So give them some consistent name if you want to do that. All 3 of the graphs are related for the Dunebuggy, and either of the 2 graphs, of the 2 other graphs or original data can be reproduced. All of the other 2 graphs can be reproduced at least partially from any of the 3 graphs. So, can I use data from this graph to reproduce this graph? Yes. Can I use data from this graph to reproduce this graph? Yes. Can I go backwards? Almost. I'll tell you about that. How do I find the slope for this? Okay, so this one, what is the slope for this? It's 0, isn't it? Pretty close to 0. So what is the value of the intercept of this graph? It's pretty much 0, right? Right. Now, for our buses, we have this for our distance time graph, right? And which means we don't get a slope, because the slope is always changing. But what that does mean is that on our velocity time graph, we really could get the slope at any point. If I put these side by side, if I put these one on top of the other, like this, and I want to know what's the slope at this point. What is the slope at this point? You know what the slope is? It's whatever that value is, isn't it? Right? So this slope is getting steeper and steeper. It's increasing. What is this doing? It's increasing, isn't it? So the slope at any point on this graph is just the numeric value on the other graph. Right? It's the same here. The slope at this point right here, at any point on this graph, well, it's always the same, isn't it? It's all the same slope. It's just the numeric on this graph, which is all the same. But the same thing applies for the bus. And whatever the slope of this is, that's going to be equal to the numeric value, which is not 0, for the bus. Right? But anyway, we were just talking about, can we go backwards? You can take the data points from here and graph them, and then you can take these and graph them. You can almost go backwards. The only real problem is that this graph right here, acceleration is showing a change in velocity, but you don't necessarily know the starting velocity, right? So you don't know the starting velocity here. I know that something is moving at constant, right here. If I pick a spot right here, I know that it's moving at constant velocity because it's not accelerating. But what is that constant velocity? I don't know. So I can't quite go backwards unless I have a starting point. But I can go forwards on all of these. Okay? So the data is very, very relatable in that respect. Now you do the bus the same way. So we talked about the car. You talk about the bus the same way, which I haven't done. And let's talk about error. Let's talk about error. We're not going to, I suppose it's not going to go any further. Okay. There. So what about error? Because that's something that needs to go in your analysis. It says, describe the limits of the equipment and or procedure that affected the precision of the results. On these graphs, I've got a couple of points here, got a couple of points here, I got a couple of points here. Would I know this better if I had more data points? Yes, particularly if I had finer resolution on my time. Now, if I had more data points way out here, probably not, right? That's just doing the same old thing, going up, 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 like that. But if I had more data points, I might get better results for indicating where I was not looking at constant velocity and stuff like that. Well, those spark timers do have another setting. We had it set on 10 hertz. We could have set it on 60 hertz. We had a lot more data points to plot. We have 6 data points for every 1 data point that we had. But could I get a better, curve fit from something like that if I had 6 points for every 1? So you can discuss that in your considerations. Describe the limitations of the equipment or procedure that affected your results, and include ways that you could fix those. So determination of the period of acceleration, period of acceleration, this is how first period or second period got it, was not precise due to the, I would say something like coarseness of the time intervals used by the spark timer. Okay, so I've described a limitation and how it affected my data. The data could be improved by using a higher setting, such as 60 hertz. Right? So I've discussed one of the limitations, and I've suggested how it could be improved. You should always focus on the major limitations to your data. What about your measuring? Measuring of the change in distance could be improved by whatever, okay? Got a ruler. So the less resolution we have in our data, right? We were 3.1 centimeters. What about if we said 3.06 centimeters. That give us a little better. We're real careful about our measurements. Right? So these have an effect. What else? When we have these sections of spark timer tape with our marks between them, so this is our first one. So this is 1, 2, 3, and this is 3.5, 3.9, 4.1, and then so on, 4.1. So we can see that it's getting a little bit faster and faster, but is 3.5 is the distance that it covered, 3.5 centimeters in one tick. Is that how fast it was going for that entire tick? It was the average velocity, wasn't it? So each one of these time intervals, this is the velocity, this is the average in time 2, and this is the average in time 1, and this is the average in time 3. So really, there's the potential of acceleration during this entire time. You can talk about that. So we talked about the fineness of our data. Well, that also affects the fact that these big chunks of time are all averages for a whole big chunk of time, right? I say big chunk of time, 1/10 of a second. But that's just an average distance that it traveled for all of that time. When we did that subtraction, this minus this, that's how much it changed in that period of time, but it's still a change in the average velocity, right? It's not any kind of instantaneous velocity or something like that. So all of those can be discussed as sources of error. Finally, last thing, let's talk about the conclusion. Answer the following questions. How well did the lab fulfill its purpose? Why or why not? Write it in such a way that the reader could establish the original purpose in your answers. So original purpose from our answers. So I didn't write this up either, but we'll just talk through it. So our original purpose in our conclusion. So something like graphing of 2 toy vehicles, one moving with constant velocity and the other accelerating, showed that distance time, velocity time, and acceleration time graphs are related within the same data set or same set of data. Values for slope of the distance time graph predict the intercept for the velocity time graph, and so on. Right? Weren't those some conclusions that we came up with from looking at our graphs? A couple, 3 sentences is all it takes. All right? And we can establish most of our purpose from stuff like this, that we were going to graph some stuff and generate some relationships between the graphs. And those are our last few points. For scoring, how were they obtained and recorded or calculated? So we recorded some data from distance time graphs, and we clearly showed the relationship to the objective. So if I want to make sure that it's clear how I got the data, graphing of maybe something like spark timer data obtained from. So there, now I've included where this came from. Graphing of spark timer data obtained from 2 toy vehicles. So I've told you where the data came from. Was this helpful? Okay. So this would be a high-scoring lab report. I might knock off a point or two on myself if I went through this at the same time as I was reading it instead of trying to write it on the board for you. But I might look and say, "Ooh, I misspelled that," or "Oh, I didn't do that. I left out that piece," like this. Like, oh, it's here. So go back and write it in. But the point is, this is the way this kind of a graph or thing should look like. On Monday, we're going to start something completely new. We're going to start free fall acceleration. So, ball go up in the air, falls down, that sort of thing. We're going to do that for a couple of 3 days. We're going to do that. We're going to do another lab, which thankfully will not require a big long write-up like this. It'll just be some tables and some graphing, and then you'll be done. And it'll only be really one big graph. How many of you are in pre-AP? One, 2, 3, 4 or 5 of you, I thought. Anyway, do you guys remember the ball toss with where we had the graph that looked like that? Right? We're going to do that. But we're going to press it down into like a day and a half. Yeah. You guys will bring your Chromebooks in.